Hi, welcome. In this video, we will solve problem Pacific Atlantic water flow asked by companies like Amazon, Microsoft, Facebook, Google, and many others. Now let's check out one more problem on graphs, Pacific Atlantic water. So there is an M cross N rectangular grid. Okay, so here you can understand like this is 5 cross 5 where 5 is M and next 5 is N. That borders the both Pacific Ocean and Atlantic Ocean. So here you can see there are two different colors. So you can see that this is your Pacific Ocean, okay, and this is Atlantic Ocean. Okay. The Pacific Ocean touches the island's left and top edges. So you can see the Pacific is island's left. This is my island. This is the island. Island's left and top touches are done by Pacific Ocean, and Atlantic Ocean touches the island's right and bottom. Okay. The island is partitioned into a grid of square cells. You are given an m cross n integer matrix, heights, where height of row and column represents the height above the sea level of the cell at coordinate RC. So basically, if you can see, this is 5. So 5 is basically the height above the sea level. Okay. So here you can see this Pacific Sea. Okay. Pacific Ocean, Atlantic Ocean. So these are basically sea level. Okay. Sea level, and 5 is height above the sea level. Okay. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west. That means there are 4 directions: north, south, east, and west. Okay. And the neighboring cell's height is less than or equal to the current cell's height. Okay. So see, water basically flow. Suppose here is water. Okay. This water will flow in this direction if the height is here, that is less than the height of here. Okay. So here is 5, here is 4. So basically water will flow in this direction. Okay. This is the basic thing, right? Suppose this is one height 5. Okay. And if this is one height 6, so water won't flow, right? Water will be trapped here. Okay. But water will flow here in this direction. Okay. So basically this is the basic saying that height should be lesser than to flow. So let's take out this example. Here you can see we have 5. So from 5 the water can flow here in the north, here in the east, south and west direction, because all these points are lower than the current point, that is 5. Okay. Vice versa, here you can see, suppose if I am taking the next point as 3, so you can see water can't flow here. Okay, water won't flow here. Mm. Also, water won't be flow here. Water can flow only in this direction. But from this, water can't flow here, right? Because 2 is lesser than 3, but here 2 is lesser than 3, so it will be trapped, right? Water won't flow. Water flow here because these are at the same point. These are at the same level, right? So you can see water will only flow if the height is less than or equal to the current cell's height. Water can flow from any cell to adjacent to it, to an ocean, into the ocean. Okay. So basically from any cell to its adjacent, and adjacent, that are 4 direction adjacent, that is north, south, east, west. Okay. So we need to return a 2D list of grid coordinates result, where result of I represents the row and column, denotes the rainwater can flow from cell to both the Pacific and Atlantic Ocean. So basically the water can flow in both the Pacific and Atlantic Ocean. Okay. So here is this grid. Let's see what will be the answer for this one. Okay. So here we have 0, 4. So here you can see from 3, right? If we have here water. So here you can see water can flow in this direction, because if you can take here, right, all the border cells will can flow to here direction, right? Basically to this direction, all these cells. Similarly, right, all the border cells can flow into in this direction, right? Here this can flow to this direction. Okay. Here this can flow to this direction. So if you can take here, right, we have this 5, right, that can flow in both Pacific and Atlantic Ocean. Here we have this that can flow in both Pacific and Atlantic Ocean. So that's why there is 0,4 and 4,0. That is for true. Okay. Now from here, you can check this point. From here, water can easily flow from this direction, 4, 4, same level, right? And from here as it can flow to same direction, basically here to the Pacific Ocean. So that's why this is 1,3. Okay. Now let's check 1,4. So from here, if you can see, water can flow in this direction, and from here as well, right? Water can flow in this direction. So if it is taking this path, so this can both flow in this direction. Okay. Then we have 2,2. We have already checked, right? From 5 to 3 to 1, it can flow in Atlantic Ocean. From 5 to 4 to 2, it can flow in Pacific Ocean. Okay. 3,0. So here 3,0 from 6, it can flow 0, 1, 2, 3. Yes, from 3, it can flow to here, Pacific Ocean. And from, I guess, 6, if I am taking 6 to 4. So basically here, from 6, it can flow here, Pacific Ocean. And from 6 to 5 to here, it can flow in this direction, right? So 3,0, then 3,3, same reason, 7 to 6, then Pacific Ocean, 7 to 1, to then Atlantic Ocean, and all done. Right. So basically, if I check what will be my answers, right? My answer for this one will be, right? This is 1 point. This is 1 point. This is 1 point, and we have this point. So from if water is here, it can flow in both the Pacific and Atlantic Ocean. Okay. So let's see how we can solve this problem. Now let's understand this problem. Okay. So let's understand the few important things that is given. So basically, from one island, from one point, you can travel in 4 direction. Okay. So that is north, east, west, and south. Okay. And the water can flow. Okay. Basically, the water can flow only when if the current height, okay, suppose h1, okay, that is your current height, or let me say, suppose hc, okay, if hc is greater than or equal to adjacent, okay, he, that is current height, okay, basically current height and adjacent height, okay. If current height is greater than the adjacent height, then only the water can flow. Okay. This is the condition, then only the water can flow. So now how we will solve this problem? Okay, how we will get to know that water can flow both the directions in Pacific and Atlantic Ocean? To take a note of it. Okay. So from this thing, we can very clearly understand, right? All the border elements can, let me put it here. All the border elements, right, can flow to its adjacent ocean. Okay. So this one, this one, this one, this one. Okay. But from here, we can see, right? Those are in what I will say right diagonal can flow in both the Atlantic Ocean and Pacific Ocean. Right. Okay. So one way is basically you will check each point, right? One, you will check, will it be, so here you can see from one, we can quickly say that it can flow to Pacific Ocean. For Atlantic Ocean, we will check for, can it pass here? No, it's not. So then we will check, can it pass here? No, it's not. Can it pass here? Yes, it is. So from here, we are not going to Atlantic Ocean. So that means this point is not going to give our answer. So what we can do, we can create a track of it. Okay, or we can create a grid or put 0, that this this row and column, basically this row and column is not giving a result. Okay, similarly we can take 2, and then again we can start right from 2. I can simply move to here, that is Pacific Ocean, because if I is less than 0, okay, j is less than 0, that means I am at Pacific Ocean. Okay, so this is one way. But if you are doing this one, so basically what you are doing, you are trying to DFS to all the n cross m elements. Okay, right? You will apply DFS into n cross n elements. Okay, and what will be the, basically again DFS will be on 4 directions, right? So 4, basically it will be, the time complexity will be big O of n cross m into 4 because you will apply 4 DFS operation into n cross m elements, right? And also, right, it will be greater because 4 will have also further 4 directions, right? Okay, that is also one thing. And we can't say that all each cell will be visited once. Yes, we can create a track of it that each cell will visit one. If I have visited the same cell, I won't visit it again. That we can do. But again, right, it will create like very high. It will be a bit of problematic. It will take more time, right? If you are going with this approach. Okay. Apart from this, what we can do, we know that these are the ocean levels. These are the ocean points, or basically this row. What I will do, I will traverse from this row, right? I will traverse from this row, and I will check what are the available points there water can flow. Okay. If the from here, right? From here, if the water can flow, I will mark it Pacific first, right? Then again I will start, and if the water can flow, suppose, right? So basically I will take these row points. Okay. I can directly say that these row points are my Pacific ones, right? Like here, these points easily can like flow to Pacific Ocean, right? These points are also are my Pacific points. Okay. Now from here, if I am able to reach at this point or this point from here, again by using DFS, from here, if I am reaching to this point or this point, I will say that the water can flow to here, right? Basically, see, this is a simply I am doing the opposite logic, right? Okay, completely the opposite logic. What I am saying, okay, basically you know that water from here, water can flow in this direction, okay, and then we are deciding. So basically, then you have to apply DFS for all the n cross n m elements. But what you can do instead of this, you can take these elements, right, the first row, and what you can do, you can check, right, can water can flow from here to here like this one. If it is possible, what you will do, you will mark that from here, basically from here, see, the water can come here. So basically, the water can flow in this direction as well. Okay. Okay. The condition will be opposite. The condition will be opposite. So basically, the current height should be greater than adjacent to flow in this direction. But when we will reverse it, so we will say our current height should be lesser than the adjacent. Okay. Then only the water can flow. Right. So basically, if my water is here, right, and I want to consider that this point, basically 4, is will water will reach to 4 or not. Okay, let's forget everything. Let's see this thing. I'm at 2. I just want to check, can water reach to 4 from this point? So what I will do, I will say, if my current height is lesser than the adjacent, yes, water can reach. And that's true, right? So basically from here 4, the water can reach to 2, then 2, then simply to the Pacific Ocean. The same thing is true, right? If I am at 2, and if the adjacent height is greater than the current height, I will say water will reach here. So basically, I have taken this point. I am checking, will water we reach here? Yes, it is. From 1, it can reach to 3. Okay. From 3, can it reach to 2? No. Why? Because see, check the opposite side. From 2, can you reach to 3? No. So that's why I am checking. From 3, I can't reach to 2. The height should be lesser than the current height. The height should be lesser than the current height. So what I will do, I will check from 1, I can reach to 3, and from 3, I cannot reach to 2, and that's the end point. Okay. From 3, I can't reach to 2. That's the end point. So from 1, I can reach to 2 only. From 2, I can reach to 2. Okay. And from 2, I can reach to 4, right? The height should be greater than. Basically, the current height should be lesser than. So if these are the things, right, I can say, yes, I can reach to 4. So this will be marked with Pacific Ocean. This will be marked with Pacific Ocean. This will be marked with Pacific Ocean. This is also marked with Pacific Ocean, right? From 2, can I reach to 3? Yes, it is. I can reach to 3. From 3, can I reach to 5? Yes, it is. I can reach to 5. Okay, can I reach to 1? No, right? And from 3, basically, can I reach to 4? Yes, it is. From 3, can I reach to 2? No, right? So this I cannot reach. So this will be marked as specific, this will be marked as specific, this will be marked as specific, this will be marked as specific. Okay. Similarly, what we will do? The same thing we will do for the Atlantic Ocean. So from here, I will just say that suppose this from here, Atlantic water can reach. Here, Atlantic water can reach. Now from here to here, can I reach? Yes, it is. I can reach. From here to here, can I reach? Yes, I can reach. So basically, I will add these points, right? From here to here, can I reach? Yes, right? If my current height is lesser than the adjacent, I can reach. Okay. So I will basically use this condition. So this is how we are basically going to solve this problem. Okay. So let's see, let's create few things so that get the approach of this problem. Okay. And then we can start implementing it. Okay. So let me quickly create two grids. So now let's see what will be the approach to this problem. Okay. So basically approach one, if I say, I will start from the first row and the last row. And you can see here I have two grids, right? So one is this grid. Suppose this is for Pacific Ocean. Again, I am just doing to mark this. Okay, I will tell you. This is for Atlantic Ocean. Atlantic Ocean. So basically, why I'm using this grid? So basically, these grid indexes I will mark where the water can reach from Pacific Ocean to that grid. Okay. So I will take the first row and the last row. First row will be for Pacific Ocean, last row will be for Atlantic Ocean. So from first row, all the first row elements can reach to Pacific Ocean. Yes, so I will mark all these points to 1. Okay. Basically, then I will apply DFS, right? So I get to know from here I can't reach it here, but from here I can reach here. So I will mark this one as 1, right? Now from 2 I can't reach here. I cannot reach here. Both are greater than, and basically I can't reach here 4. Okay. But yes, when the points are greater than, like 2 is greater than 3, 2 is like 3 is greater than 2, 3 is greater than 2, 4 is greater than 2. So water can flow from these 3 direction, right? So we have to mark this one as true, right? This one also true. 4 is also true, right? And similarly, you can see for 5, right? Water can reach from 3 to 5. So I will mark this one. Similarly, I will do with the Atlantic Ocean. I will mark this one as 1, this one as 1, this as 1, right? All these points. Okay. Then I will check from 5 I can reach to 6. So I will mark this one, right? I will basically apply this one. From 1 I can reach to 7. So I will mark this. Okay. Similarly, the same principle I will do with here. I will take the first column and the last column. So basically, when I'm taking first column, so in the Pacific, I will mark this as 1. I will mark this as 1 here. Similarly, in the Atlantic, I will mark all these points are as 1. Okay. Now let's a bit of quick complete it. So when I will simply put these things, right? So from 3 we can reach to 5. From 3 we can reach to 4. Right. And from 4 we can't reach to 3 because this is lesser than. From 4 we can reach to 4. Okay. And from 4 can I reach to 1? No. Right. So from 4 here I cannot reach. From 5 I can reach to 3. Right. Okay. Then 3 I can reach to 1. Basically, if you can see, basically water is flowing. If I can reach 3 to 5, right? Water can reach from 5 to 3, then 3 to like this one, right? Similarly, water can reach from here to here. Okay. But that won't be the Pacific water flow. Sorry, my bad. Right. See, from 5 is greater, 3 is less, right? What we are checking this. If this is 3, right? The 5 should be greater. So 5, when 3 is less, so water cannot reach here, right? Atlantic water can reach here. Okay. So basically, if I check, the Atlantic water can reach here. So let's first fill out the Pacific one. Okay. So 5, this is done. Now from 4, can I reach to 7? Yes, I can reach to 7. And from 7, can I reach to 1? From 7, can I reach to 6? No. From 7, can I reach to 1? No. Right. So that is done. From 5, can I reach to 1? No. Again, remember that's the opposite, right? the current height, okay, the current should be lesser than the height of adjacent. Okay. So from 5, can I reach to 1? No. From 5, can I reach to 3? No. Then from 3, can I reach to 4? Yes. So from 3, we can reach to 4. But 3, there is no water, so we can't reach it here. Okay. From 1, we can reach to 5, but at 1, we have no water, so we can't reach to here, this point. Okay. Now this is, I guess, this is the end because we are not able to reach any point, right? Yes, 5 water can Pacific water can reach to 5, right? But it cannot reach to 1 because 1 is smaller than the 5, right? What we want greater. So this should be greater. Okay. I cannot see here. So from 2 it is 3. Okay. So it is not greater. So I guess this is the only points. Okay. Now let's fill Atlantic water. Okay. So here from 5 we can reach to 6. Yes. From 6 we can reach to 2. No, we cannot reach to 2. From 1 we can reach to 7. From 7 we can reach to 4. No. From 1 we can reach to 1. Okay. That is true. From 1 can I reach to 5? Yes. Okay, from 5 can I reach to 3? No. From 5 can I reach to 4? No. Right. From 5 can I reach to 3? No. Right. From 2 can I reach to 4? Yes, 1. From 4 can I reach to 3? No. Right. That is also done. From 5 can I reach to 3? No. So here, let's see, from 2 can I reach to 4, but from 4 I cannot reach to 3. Okay. This I can reach. From 1 can I reach to 3? Yes, from 1 I can reach to 3. From 3 can I reach to 4? Yes, it is. Okay. From 4 can I reach to 3? Okay, no. From 4 I cannot reach to 3. So I guess this is my Atlantic water flow, right? Basically if water comes from the Pacific, so basically what I have drawn, if water comes from the Pacific, right, it will reach here like this, right? So these are the grid points there water can reach. If water will come from the Atlantic, okay, the maximum height, the maximum row and column grid the water can reach are these points. Now what I need to do, I just need to check what are the grid elements where the water can reach both the Pacific and the Atlantic, right? So these are the grid elements right here, right, where water can reach. This is also one of the, okay, this is also one of it. Okay. Now here, this is also one. Okay. This is here. This is in the field in Atlantic, but not in the Pacific. Okay. This is filled, these two. So these two will be 1 points and these. So you can see, right, in our answer as well, right here, 1, 2, 3, 4, 5, 6, 7. And here we are also getting these 7, right? 1, 2, 3, 4, 5, 6, 7. Right. So these are the points. Basically, this is how we will track. Remember, because we are starting from Pacific, right? So the conditions will be changing. Okay. Now see, there is only one thing that you need to remember. Okay. Because in the diagram I have shown here, like from 2 you can reach to 2 and from 2 you can reach to 4 because 4 is greater than it. Okay. So you can reach it. But see, you won't be able to access it. What you will do, you will call DFS, right, from here 4, and you will check, right, is 4, basically is 4. Okay. You will check the previous, you will check from the previous, right? If it is lesser from it, sorry, not lesser, greater. If it is greater from it, then you can reach it. So basically, you need to check with your previous element from where you have come, right? You should be greater from it. Okay. Suppose, right here, 2 can, Pacific can reach to 2, right? So I can compare with the same elements, right? But 2 here, I just need to check, is it equal, right? So I can simply reach it here. Now I can reach to 4 because 4 is greater than 2, right? So these are the conditions we are going to basically use. Okay. And now we can simply jump to our code implementation part. Okay. Before that, I can tell you what are the things that we are going to do. Basically, we are doing with the one row, right? Basically, we will apply DFS on the row, right? And then we will apply in the last columns, right? So last rows, basically top and bottom rows and top and bottom columns. then our DFS function will work. Basically, then we will apply the conditions like we should not reach here, okay, because we are starting from here, right? We are moving in this direction. Remember, we are moving in this direction, right? In this direction. So we should not come here. That means I should not less than 0, j should not less than 0. Right? Here, what should be the condition? Okay, here should be the condition like I not reach, j should not be less than 0. This is the condition, right? J should not be less than 0, right? Here, that is I should not be less than 0. Here, I should not be greater than equals to n, right? Here, j should not be greater than equals to n. These will be the 4 conditions. Okay. So now we are pretty clear with the approach. Now let's quickly move to the code implementation part. Okay, we will do the complete code implementation, and then in the last we will check out the dry run of it. Okay. So see you in the next video where I am apply the code implementation part. Okay. So yeah, see you in the next video.